Hi everyone, welcome back to Rafa Tech TV. Have you tried to implement TLS end-to-end inspection as part of your design of the zero technology strategy without having to sift through a lot of documents or doing trials and error? Look no further, because in this video I'm going to teach you how to build and design PKI services and integrate it with Azure Key Vault. Now, if you look through to the end of this video, you're going to see how we automate certificate deployment to our endpoint. If this looks like something you're looking for, please like, share, and subscribe. Follow me on this journey. Thank you. In today's security landscape, organizations are rapidly adopting zero trust architecture to protect their data and services. One crucial element is the TLS inspection, and this can be found as part of the services provided by the Azure Firewall, which is ensuring that connections from Windows or Linux endpoints to cloud services remain encrypted and monitored. Let's be honest, manually managing certificates can be a nightmare. That's why you need a robust and automated solution. In this video, we are going to design a private public key infrastructure PKI services and integrate it with Azure Key Vault that will help us store the output of the PKI services, which is the root certificate. This approach helps us to generate and store and deploy the certificate seamlessly without compromising on security or agility. The question is, why do we want to use these services? What is zero trust strategy in the first place? Now, this takes us to this diagram. Azure Security brought about zero trust model, and this is a high-level diagram of what it looks like. In this diagram is that when communication that is coming from outside our environment goes into our environment, especially when it is going to access an endpoint, it should first be able to hit the Azure Firewall. And the Azure Firewall in this instance is going to decrypt and re-encrypt this traffic after it has checked it. And after it has perform those actions, it is going to check if this is an attack or a legitimate traffic. Now, according to zero trust model, we should only not just check what is coming into our network or going outside our network, or what is coming into our network, but also what is going outside our network. In that, even the communication that is coming from our endpoint back to the internet should also be cross-checked to ensure that it is not taking data that are valuable to our organization through a legitimate means. Now, as part of this zero trust model, what we are talking about today is the underlying resources that are supporting the Azure Firewall, and that is the Azure Key Vault, and how to create a private PKI services. Now, question that may be asked is, why are we using Azure Key Vault? I want us to know today that the Azure Key Vault, simply put, it is the forkness for your secrets and certificates. It is the place to manage cryptographic keys, secrets, and policies at large scale. Combine that with the use of managed identity, and your VMs or your apps can authenticate to Key Vault without storing password either in the code or anywhere else. By offloading the credential management to Key Vault to handle, you reduce the attack surface significantly and streamline how each resource accesses the Key Vault. The synergy between the Key Vault and the managed identity is the bedrock for a secure automated certificate distribution system in Azure. Now, what is this private PKI design? As part of implementing the Azure Firewall, there is a requirement that has been put together by Azure for Azure Firewall to be able to perform its task. And this is the PKI design, the PKI services. Now, in the PKI services, the Azure Firewall requires a root CA and intermediate CA. Now, the root CA will be stored inside the endpoint, while the intermediate CA will be stored on the Azure Firewall. The Azure Firewall is going to use the managed identity to assess the key vault and be able to use the intermediate CA. Now, the requirement for this is that it should be at a default bit of 4096. And we are also looking at a signature hash algorithm of 512 bits. Now, what is necessary in the PKI design is to have a root CA, and you can see the extension on the screen where the root CA has a basic constraint, thereby acting as a CA, and it identifies as an issuer. Now, the inter-CA, on the other part, has a basic constraint, or that's a CA, but also a path length, that one, which means that it could issue and sign certificates by itself, as long as it has been signed by the inter-CA has been signed by the root CA. So the root CA can issue and sign certificate. This thereby makes it possible for traffic that has been encrypted and decrypted at the firewall level to also be able to transport it to the endpoint where the inter-CA, where the root CA will be kept, and it will be able to decrypt that traffic when it gets to the endpoint. Now, the question is, how do we intend to implement this? This I have done in our Visual Studio Code. Here in our Visual Studio Code, I have created what should be the foundational resources that are going to make up the PKI design. Now, for the PKI design, we are making use of a deployment script resource. In the deployment script resource, we are going to put our OpenSSL command that embodying that PKI design. Here, it is going to have those commands that helps us create the intermediate and the root CA. If you want to know what this command look like, I will put the link in the description for you to have a further look at that. Now, a bit of information on deployment script is that deployment script have on background resources that helps it operate properly, which is the container services and also a storage account. Now, these resources automatically be cleaned up after it has been deployed, after a successful deployment of the deployment script. Now you will see in the deployment script that there is a part that says clean up preference. You can choose to clean up on success, or there are other options that you can choose. Now, even the output of the deployment script, you can choose the number of days that it could stay. It is being deleted. Now, as we have said earlier on, we are going to combine our key vault with our managed identity. This is to ensure that we control what comes into our vault to check secrets. And I have used access policy as a way for access into our key vault over here. So we are deploying just 3 fundamental services to help us create our certificates, store our certificates also in the key vault. Let's see how it goes. So the first thing that we do first is to validate our resource builds. We can see that validation has come forth that this can be built. So what we will do is to create the key vault, is to create these resources. Diving deep into the architecture, what we're doing at the moment is spinning up a private PKI that issues certificate for our TLS inspections need. Here, where Azure Bicep comes in, a powerful infrastructure as code solution that makes deployment both modular and repeatable. In this key snippet, we define our Azure Key Vault and set up a self-sign certificate using the deployment script. Now, because we are going to access this key vault from another template, it is also important that you put the enabled for template deployment to be true. Our deployment is going on in the background. Now, what we have seen here is that our deployment has largely been successful. Now we are going to the fun part. The one to check is to also see if we can access these certificates that are stored in our key vault and have them as parts of our endpoints. So here we have defined an endpoint resource in a virtual machine, which is going to be a 2022 data center Azure VM. And in this VM, we have given it the managed identity for it to be able to access the key vault. The same managed identity that we have created and attached to the key vault, we have given it to the VM to attach the key vault. And the fun part of this that I remember stating that earlier is that we are going to use something called the getSecret function to be able to fetch the secret. Now, I'll tell you the reason why I'm using this. There are situations where after the foundational resources has been created, you are being asked to fetch secrets, and this secret from this key vault and where you're searching it from are from a different scope. And there might be this issue about how to fetch this key vault. Now, what I meant is that you might have a key vault in let's say sub A, and you are asked to fetch the secret for to be used in a VM from sub B, which altogether would be a different scope. Now, what do you do in this instance? This is where you could use a getSecret function. Now, a getSecret function can be used in two ways. You can use it as part of a module, and you can use it as part of a Bicep parameter file. In this video, we are using getSecret function as part of a Bicep parameter file. So let's go back to our Visual Studio. Now, in our Visual Studio, In our Visual Studio, we have the Bicep parameter file as the fetch the secrets Bicep. Now we have defined the VM, like I said earlier on, and we have we have defined the landing zone where it will be landing into, and likewise we have defined routing for our VM as well. And likewise, we have defined a Bastion solution to help us sign into that VM, as we don't want to access the VM from RDP to the VM through a public IP address. Now, we have also used extension called the Bootstrap extension. This extension where we have put a protected setting for command to execute, that the certificate that has been fetched through the get function, the getSecret function, will be converted to a base 64 and then be added to a trusted root certificate. Now, how do we use the getSecret? What does it entails? The getSecret entails a decorator, a secure decorator as a parameter, and that parameter is what you use in calling the secret, in calling that secret. Now, let us test and validate that this works. We are back to the holy grail of commands, which is the Azure CLI deploy template command. And here we are trying to validate that our key votes can be found. Now, there is a bit of change in the name of the key vote. So we need to update that, and then we validate again. The virtual machine. Once our endpoints, in this case, the virtual machine, has been able to grab the certificate from the key vote, they can perform end-to-end TLS inspection and ensure that traffic is secure, encrypted, and properly managed. I tell you, this is a key pillar of a zero trust architecture. I'm going to have to show you what's happening on the screen at the moment. So we have the fetch secrets deployment going on at the moment, and this is where it is creating the VM. Now, as you can see that the VM has been created, it is adding the extension, which is the Bootstrap extension, to that VM at the moment through the help of the managed identity. So let's go back to our design and see what we have been able to achieve. So we have been able to create a root certificate, and we have been able to create an intermediate certificate. The root certificate will be stored in the virtual machine. Please don't confuse what is happening on the screen at the moment. The root certificate will be stored in the virtual machine, while the intermediate certificate will be stored in a key vault. And will be accessible by the firewall. This is how this works. Thereby, we have already certify from our design that intermediate CA will be able to create or generate certificates that will go with the traffic for what it has decrypted and re-encrypt with its own signature for the root certificate that is in the virtual machine or probably our endpoint, either Windows or Linux, and for it to be able to decrypt it. The endpoint has the root certificate that signed the intermediate certificate. So this is how you design and deploy an end-to-end TLS inspection framework with a private PKI using Azure Bicep and Key Vault. By automating certificate generation and distribution, you have removed human errors and complexities, thereby strengthening your security posture. Now we're just waiting for the deployment to be successful, and then we are going to sign in and check. If you've gotten to this end of the video and you find it helpful, please be sure to hit like buttons and subscribe to stay updated on the latest Azure development, Azure and DevOps content that is coming from our page. As you know, this is just the part one of the Zero Trust architecture, as we hope to also deploy an Azure application gateway, an application firewall, and get the Azure Key Vault to send the inter-CA to the Azure firewall. Then we can check end-to-end traffic that is going to our endpoint as much as going to our web app. Here we are also going to look at how to implement IDPS as much as TLS inspections live and how it works. This is going to be in a part two video. So subscribe, share, and comment. The rest of this video is just for us to confirm that our certificates can be found in our VM. So we have a VM deployed now. What we're trying to do at the moment is just to update our password. And then once that is done, we will be able to sign in. If you have any questions, please don't hesitate to send it in. I'm very happy to help. And please stay tuned for our next video as we will integrate this certificate with the application gateway and Azure Firewall for even deeper network security. Here is our certificate manager, and right inside that, we could find our self-signed certificate, root certificate. I would send this Bicep into the repo and in my GitHub. Please look at the GitHub for updates on this Bicep. Thank you for listening.